Section 3.7, triangle congruence, angle side angle and angle angle side. So now we're going to talk about the very last two shortcuts to show that triangles are congruent. We've already learned side, 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 side angle side, and hypotenuse leg. Now we're going to learn two more, angle side angle and angle angle side. These are all the shortcuts to show that two triangles are congruent based on a little bit of information. Because remember, other than that, the only way to know that two things are congruent is if you know that all the pairs of sides are congruent and all the corresponding angles are congruent as well. But triangles are special. If you know a little bit of information, you know they're congruent. So first is angle side angle. This states that if two angles in two different triangles, so angle A is congruent to D, angle C is congruent to angle F, and the included side, meaning the side that connects those angles. If that side is congruent, then they must be congruent by angle side angle. So ABC is going to be congruent to DEF by angle side angle. And make sure for angle side angle, it's the side that's in between or connecting those congruent angles. If not, it might be angle angle side, where if you have two equal angles, once again, I have angle A is congruent to D, I have angle F is congruent to C, but notice the side that connects them is not marked. That's okay. It's not angle side angle, but if they have a corresponding side, meaning this side is connecting the two marks, that's equal to the side over here connecting the two marks, then they're going to be congruent by angle, angle, side. So it's all based on where is that equal side located. In between the angles, angle, angle, side. Not angle, side, angle. So let's try this out. Determine whether they're congruent or not. If so, state which postulator theorem you used. We have 5 options. We have side, angle, side, 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 HL, angle, side, angle, or angle, angle, side. Well, in A, I have two pairs of equal angles, and the side that connects them, that's in between them, is congruent. So yes, those are congruent by angle, side, angle. B, they share a side, so I can say that side equals itself. They have two pairs of equal angles. The side that connects them is not equal, but the corresponding side shared by them is congruent. So that is going to be yes by angle, angle, side congruence. Now C, yes, we've got vertical angles in the middle. I can add that they're equal. But I don't know anything about the sides at all. In order to know that triangles are congruent, I need to have at least one equal side somewhere. Every single shortcut involves a side somehow. There's no information about the sides of these triangles, and just because the angles are equal doesn't mean they're the same size. That's something else. So no, we don't have enough information there. We need to know at least one pair of equal sides somewhere, and we do not have that in this diagram. For problem D, I can add that the vertical angles are congruent in the middle. Now I have two pairs of equal angles, and the side that connects them is equal. So that's going to be yes by angle, side, angle. Determine whether your triangles are congruent or not. If so, state what postulate you used and write a congruence statement. Okay, so we've got 5 choices: side, angle, side, 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 hypotenuse, leg, angle, side, angle, or angle, angle, side. In A, I have two pairs of equal angles. The side that connects them is not marked, but a corresponding, hey, that's connecting the two marks. That's equal to the side that's connecting the two marks. So that's going to be yes by angle, angle, side. And the triangle on the left, I'm going to call that LNM. So I start off with L, which was unmarked, so I have to go with P, which is unmarked. Then N had 2 marks, R has 2 marks, and then M had 1, and Q has 1. B, again, these are right triangles. The side across is called the hypotenuse. Now, I don't know that the hypotenuse is equal, so I can't use hypotenuse leg here. So once again, just because it's a right triangle, it doesn't mean you have to use hypotenuse leg. However, they have 2 pairs of equal angles, and look at the side that connects them. They share that. That side has to equal itself. So those triangles are going to be congruent by angle, side, angle. Let's name the triangle on the left. I'll call it STW, which was the unmarked angle, so V, then T, which was the right angle, so W, and then T. C, we've got a linear pair, which means you can subtract from 180 and get that this missing angle must be 90. The angle next to it's 90, and it forms a straight line. 180 minus 90 is 90. Then they share a side. I'm allowed to say that side's equal to itself. Also, this is the hypotenuse. This is the hypotenuse. The side across from the right angle is the hypotenuse. The hypotenuse is congruent. A leg's congruent. So yes, those triangles are congruent by hypotenuse leg. The triangle on the left, I'll call that KYZ. And that's going to be congruent to XYZ. D, I have one pair of equal sides. I've got vertical angles. The vertical angles must be equal. However, I don't have another pair of equal sides anywhere. I don't have a pair of equal angles anywhere. So those are not congruent. I don't have enough information. That doesn't fit any of our shortcuts. I would need more information, which I don't have. C, they have two pairs of equal angles. They're also sharing this side. Now that side is not the one that's connecting the equal angles, but it is a corresponding, it's connecting the same type of angles. So those are going to be congruent, not by angle, side, angle, but by angle, angle, side. And the triangle up top, I'll call that VFE. I started off with V, which was 2 marks. That means D. Then I said F, which is 1 mark. So E has 1 mark, then F. F is going to be yes. By side, angle, side. They have two pairs of equal sides, and the angle that connects them is equal. So I'll call that PQR. P had no marks, was at the end of 1. No marks, end of 1 is F. Then Q had the 1 mark. E has the 1 mark. Then D. G. Now we got to be careful here because the triangle on the left angle. The triangle on the right looks like angle, angle, side. They're not showing the same thing. So that is no. They're not congruent. The left is angle, side, angle. The right is angle, angle, side. It would need to be the same thing in both in order to be a yes. H. I've got vertical angles that I can mark in the middle. Now I have two pairs of equal angles, and the side connects them is equal. So that is yes by angle, side, angle. And the triangle up top, I'll call that ABC, which I started off with A, which had no markings. F has no markings. Then I said B, which had 1 mark. So does D. And then I'll say C. All right, use the given information to write a proof. Why don't you pause the video and try these two proofs on your own. When you're ready, you can unpause and check your answer. All right, so I always want to start off with the given information. Angle 1 is congruent to angle 2. And angle 3 is congruent to angle 4. That information was given to me. Make sure you mark up your diagram. I'm trying to prove that triangle ADB is congruent to triangle CBD. Well, my options are side, angle, side, 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 hypotenuse, leg, angle, side, angle, and angle, angle, side. Well, I already have shown, I was given that I have two pairs of equal angles. So that kind of looks like I should go for angle, angle, side, or angle, side, angle, because it might be easier for me to do that. I'm 2/3 of the way there for those shortcuts. If only I could show they have an equal side somewhere. Oh, wait a minute. They're sharing this side in the middle, DB. DB must be congruent to itself from the reflexive property. And guess what? That's the side that is connecting the equal angles. So that'll be angle, side, angle congruence. Just prove they're congruent. Next one. We're given that angle 1 is congruent to angle 2. I was given that BD was congruent to BC. So BD was congruent to BC. And I'm trying to prove that those triangles are congruent. So this is what was given to me. So again, we have a choice of side, angle, side, 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 hypotenuse, leg, angle, side, angle, or angle, angle, side. Well, I was already given one pair of equal angles and one pair of equal sides. So honestly, there's no right angles. I'm probably not going to go for side, side, side. So if I could show one more pair of equal sides, or if I could somehow show another pair of equal angles, then I could use one of the remaining options. Well, in the middle of the diagram, I have vertical angles. This angle is equal to that angle. I'm allowed to say angle ABD is congruent to angle CBE because vertical angles are always congruent. And now let's take a look at it. I've just shown another pair of equal angles. Now, is this going to be angle, angle, side, or angle, side, angle? That's the side that connects the equal angles. That's not marked. So this will be angle, angle, side congruence.